Morning everyone, we were doing chapter number 7, system of particle and rotational motion. So far what we have studied in this chapter is the study of the center of mass, and I told you why center of mass is important. Okay, so let's recall first the concept of center of mass. Before that, let's understand a few points. Just recall the few points that I told you. First of all, what is the extended body? Okay, what is the extended body? It is written here. If you see the NCERT, so extended body is something, any body you see is made of a large number of particles. So we can say any body is an extended body made up of a large number of particles. Okay, now what we have done so far in the previous chapters, in the previous chapter we have considered the body to be a point mass. How can we consider a body to be a point mass? Every body, you know, is made of a large number of particles. So how can we consider that to a point mass? What we can do, we can assume that the whole mass of the body is concentrated at its center of mass. And you will see, and I told you in the class, that despite all the particles moving in different ways, I give you the example of a spinner bowling a ball. Okay, spinning a ball. So what it does, so it is rotating, okay, on its own axis, and also it is moving forward. So it is executing two type of motion, rotational motion as well as translational motion. And if you see, if you concentrate in the points of different particles, suppose this A point, if you focus on this, so just imagine if it rotates, what will happen if it rotates and it is moving forward? How will be the path of this? The path will be something like this, and you can see this is a helical path. Okay, and if you see other particles, they will also revolve and move like this, the similar way. Okay, so you see this is pretty complicated. Okay, and study become pretty tough, studying each and every particle, and each and every particle is not behaving the same way or not moving the same way. So what we can do, but if we concentrate at the center of mass, and I give you the definition now what the center of mass is. It is a point where the whole mass of the body can be assumed to be concentrated. Okay, so now and I give you the example of you holding a book or notebook. Okay, and you will see there's a point from, if you hold your book, you can actually put force on that point and the whole book is balanced. That is actually the center of mass and also the center of gravity. Okay, now if you focus in the point, this will move in the if we see this center of mass, we see this move in a straight path, or rather a parabolic path, but it is not as complicated. It is neither complicated. Okay, the other paths, other point were having complicated path, the study become very tough. So what we can do now, but the path of this center of mass is pretty straight and parabolic. Okay, so study become relatively simple. So this is why the importance of center of mass comes, especially in rotational and translational motion. Okay, so this point we can study it pretty easily. Okay, this we have studied parabolic path. So what we can do, we can assume the whole mass of the body to be concentrated at this point. Okay, and we study the motion of this motion of the center of mass. Okay, so this is the important center of mass, and I have also given you the definition center of mass. There's one more definition given in this book, is the rigid body. I told you rigid body is a body having every body is made of a large number of particles. Distance between any two particles, if remains constant, does not change, it is written here, that is we call a rigid body. No body is absolute rigid. Okay, but we can, those body which have relatively the distance remain constant, that we can see from our naked eye, we can call them rigid body. At microscopic level, we see that even in motion, no body is perfectly rigid. Okay, so the derivation part, that is not possible to do, but I will just give you the explanation and all the core concept or the main concept that you can understand, and when we have the class we can go through the derivation, etc. Okay, now I told you about the translation motion. In pure translation motion, every particle has the same velocity, that is they cover the equal distance in equal time, that is they move in a straight path. Okay, so it is the example here. And in rotational motion it is saying that different particles are having different distance or different velocities. And if you focus in this point, this the center, this is the pivot point. And I told you that in a rotational motion the pivot point is stationary, it doesn't move at all. Okay, it is necessary to have a pivot point. If there is no pivot point, no rotation is not possible. So here P1 is the pivot point, and if you see the particle here, it will have zero motion, zero velocity. Other particle will have different velocities. Okay, and the best example to understand this is a fan. If you see the fan rotating, you see the middle point, it is at rest, it is not moving at all. Other points are moving, and you see the farthest point, this is moving with the maximum velocity, it is covering the maximum distance. But this point, they are not covering that much distance, they are not having. Farther you go from this pivot point of the center, which is the axis, this axis is the axis of rotation, it contains all the pivot points. If you see, there are different points, and they have different these planes have different circles. Okay, the points are making circle, they are moving, and they are different planes. All these points, pivot point, they are passing to the axis of rotation. So the farther you go, the velocity of the particle is the maximum. It is given here too. Okay, and now we have a combination, like if you see here, this is the example of a top. Okay, top is rotating, and you see, if you have happen to see this, everyone has seen the top moving, rotating. After a time, this was the original axis, this is the about which it was rotating. But after time, when it is loses motion and momentum, so it kind of precise, it's called a precession moment. Okay, the axis now is not constant, it keeps on changing, so it kind of make this kind of path. Okay, so this is the precession, this is called a precession. You will study it in electron also, do precession. Okay, so you will see this. Okay, now this is written here, precession is given. Okay, the point of contact on the top with the ground is fixed. Okay, the point to note, this point is always constant, the axis just keep on moving, it is making this kind of path. Okay, and even in this it is given a fan rotating. Okay, but what you have seen a fan, we can, there's an option here to turn move this fan, so it will keep on rotating. So this is a complicated type of motion, but we have to make it in this chapter, we have to study only the simple type of rotation, but this is other example also given here. Okay, and this one more point that I told you, it is given in the example. You see this flower base, when it is moving like this, but when it moving like this, okay, when it is rotating and also executing rotation motion, the other points are making pretty different path. They are not, the path is not straightforward, but the center of mass, you see, this is making a parabolic path. So easy to understand from the perspective of center of mass. You always take the center of mass frame of reference. Okay, and this is a formula I told you about how to calculate a center of mass. Okay, so there was 2 points, m1 and m2, and they were from origin, they were at x1 and x2 distance from the origin. We have the formula to calculate the center of mass. Suppose it has a C point which is at x distance from the origin, same origin. So this formula will be this m1 x1 plus m2 x2 upon m1 plus m2. Considering the two masses to be equal, okay, then when you solve this, it comes out to be exponential x1 plus x2 upon 2. That is at the center. Okay, if the two masses are equal, where will be the center of mass? At the center. And you can clearly guess, if the masses, if one of the mass is slightly heavier than the other, then the center of mass will shift or will be more towards the heavier mass. Example, in the case of Earth and Moon, which is heavier? Obviously the Earth. So the center of mass will be more towards the Earth. Okay, and we have, this is for two particles, and if we have a large number of particle, n particles, then we can, what we can do, we can apply the same formula as I told you in the class, and we can do the summation over here, and we get summation mi xi upon summation mi. And what is this? If there is a body of mass particles, n particles, or n particles, what will be the sum of this all the particles that fit with the mass of the whole body? Okay, now we can clearly sum it and get total mass of the body. Okay, now they have done this for the three particles, and if the body has a coordinates in x and y axis, that is in a plane, then the center of mass will have the coordinates in x and y axis also. So the formula goes same for the y axis too. Okay, and they have done this for three equal masses. Okay, if you understand the basic idea, all this word is very simple. So what they are doing, they are moving from simple to complex. They have given us very simple example to understand of two particles. Okay, then they are moving to three particles and n particles, and then from 1D to 3D. So it's pretty to understand here in 1D, and same thing applies for 3D too. Okay, and this is y-axis. They have already done the same thing for y-axis. Okay, and they have done it over z-axis. And if we have this position vector r, I told you the position vector. Okay, so if there is it was discussed in chapter number 3. Okay, a particle is there. This is the origin. This is the coordinate axis, x and y. I'm only taking x and y. Okay, this is a particle p. Okay, x, y, it is the coordinate of this particle. Okay, so suppose from this origin I draw a vector. His head is at the p point and tail is the origin. Then this is a position vector. Obviously it is telling about the position of the particle with respect to a certain origin, and we can locate all the particles respect to this origin, and we call those position vectors. For 3D, that will be a one more coordinate will be there. So how we can write position vector? We can just say write the coordinate, like for the x-axis or the x coordinate, we give it the direction, that is the positive x direction, I cap, xi cap, yi cap, j cap, z I cap, k cap. Similarly, the center of mass will be have the this position vector. Okay, and clearly this will be summation